Hi, welcome to binary tree construction by using the inorder and preorder traversal example. So here we are passing preorder array and inorder array with 6 number of elements. Then we are calling the build underscore tree, so which is taking inorder array and preorder array with initial index is 0 and maximum index is 5. Okay, so length of the array minus 1 is 5. So now once we are calling the build underscore tree, here we are preorder index, initial index is 0, that is given here. Then we are passing the inorder array and preorder array. Starting index is here 0 and last index is 5. That's what we have passed here. 0 size minus 1 is 5 we have passed. Then we are checking starting index greater than last index, no, which is false. Now we are creating the node with pre-index. What is the pre-index is here 0. So for the 0, the index for the 0, what is the value in the pre-order? So the 1. So 1 is the value assigned to the new node. Always node will have with 3 fields. So the 3 fields are here. One is a data field and left side field and right child field. So now for a node 1 we are creating the node tree node. So then we are incrementing the pre-index. So this is 0 plus 1. So here pre-index is 0, 0 plus 1, 1. Then we are checking starting index is here in the first recursion 0, here 5. Then both are equal, no, it is false, so this will not execute. Now we are searching the data in order array that one is available or not. If it is available, what is the location? So for that we are passing the starting index is 0 and the last index is 5. New node dot data, so new node is 1, new node is 1, that is passing here, so that is the 1. So with that we are searching in the inorder tree. So here the starting index is 0 and end index is 5, the value is 1. Inorder array we are starting here 0. So here where is 1 available in the inorder array? 0, 1, 2, 3, 4, 5. So in the index number 3 which is available, so in the it is checking in order of 0 equal to data. In order of 0 is 4. Okay, 4 equal to 1, which is false, which is false. Then we are checking iteration number 0, this one iteration number 0, this iteration number 1. So in order of 1 equal to data, in order of 1 is 2, so which is also false. Then iteration number 2, in order of 2 equal to data, in order of 2 is 5. Here look at that, in order of 2 is 5, this is also false, this is also false. Then iteration number 3, then in order of 3 is 1 and data also 1, so both are matching, which is true. So index 3 is returning now, index 3 is now returning that is the value here, that is the value here, right? Index value in index is now passing into finding the left subtree and right subtree. So here for finding the left subtree we are using the inorder. The location is we are passing starting index is 0. Here inorder index is 3. This is the 3, so 3 minus 1, 3 minus 1 is 2, 3 minus 1 is 2. So in the 3 minus 1, 2. So why we are selecting in order? In order, okay, in order we are finding that 1 is available. So before the 1 the index 0, 1, 2, so this will be come as a left subtree. So 4 comma 2 comma 5 will come as a left subtree for the 1. And the uh, the pre-order index in index is here 3. So 3 plus 1 is 4. So 4 comma last index is 5. So these elements will become as a right subtree for that. So now as of now this line will execute recursion, first recursion. So in that first recursion now start index is 0, start index is 0. Then last index is here we are passing as 2, this 2, this 2. So now in this first iteration, first recursion, Now we are checking start index 0 greater than last index 2, so which is false, not executing. Now the pre-index is already incremented, so this is the pre-index. So pre-index of 1, so pre-index of 1 is this one, the value is 2. So now 2 is the new node. So new node is created with value 2. So with value 2, new node is created. Among these three numbers, this is going to be act as a root. Act as a root. So new node is created. So pre-index also incremented. Now pre-index is 1 as of now. Now 1 plus 1 is 2. Now we are checking what is the starting index, 0. So here 0, 0 here, the last index is 2. So which is not matching. So false, it will not execute. Now again we are searching the node 2, node 2 available in which location of the inorder tree. So for that we are passing 0th index and last index is here 2. The 2 is passing here, node is here 2, the 2 is passing here. So 2 is passing. Now in the search option here, again in the iteration number 0, iteration number 0, in order of I, in order of I, in order of 0 is 4. So 4 is not matching with, so not matching with 2. So here we are passing 0, end index is 2, data also 2. So here 4 is not matching with 2, so which is false. Then I is incrementing. Iteration number 1, iteration number 1, in of 1, in of 1 is 2. So 2 is matching with 2, so which is matching. So I is 1 is matching. So here the index value 1 is returning here, then index value 1 is returning here for the second recursion. And here again for new node, so new node is 2, new node is 2. So for 2 we have to find out left node. Okay, new node dot left, new node dot left. So for that, what is the start index? Start index is here 0, this 0. Then next one is in index minus 1. What is in index? 1. So 1 minus 1 is 0. So again we are calling the recursion here. So we are passing 0 is the index and 0 is here again value. So that 0 is acting as a first index, this 0, this 0 is acting as a last index. Now again we are finding the pre-index. Pre-index is now 2. So pre-index of 2 is having the value 4. Pre-index having the value of 4. So here again pre-index is incrementing by 1. So that is 3. Now we are checking start index equal to last index. So what is the start index here? 0. Last index also 0. So both are matching. If both are matching, then it will execute. So new node is returning. What is the new node? New node is 4. So 4 is returning as a left, 2 dot left. So 2 dot left is 4, which is returning now. Once it is over 2 dot left, the next line 2 dot right, we have to identify 2 dot right. So for 2 dot right, what is the index? In index, so in index is here 1. So 1 plus 1 2, 1 plus 1 2 we are passing. Then last index is here, we are passing here the last index again we are passing as 2. So here the last index is also 2 for the left subtree. Then when you are going back, so now we are calling 2 is the start index and last index is also 2. So we are checking start index greater than index, so which is false. Now new node is creating. What is the pre-index? So pre-index is 3. So what is the value available in the 3? So in the 3 we are having the 5. So 5 is the new node. 5 is the new node. Then pre-index is incrementing by 1, 4. Now we are checking start index equal to last index. Start index also 2, last index also 2. So both are matching. Both are matching. If both are matching, returning the new node. So now new node is 5. So 5 is returning here as a 2 dot right. 2 dot right. So here the for this statement we got the 2 dot right is 5. So once it is over, then still there is the pending for node number 1. Node number 1. So for node number 1, still we have to identify the node dot write. So this statement is still pending for the node number 1. So for that, again we have to identify, so what is the in index plus 1? For the node number 1, 3 is the in index, so 3 is the in index. So 4, then last index is 5. So we are passing that, so 4 comma 5. So when you are passing the 4 comma 5, now the start index is 4 here, then uh, 4, then here last index is 5. So here we are checking start index 4 greater than 5, which is false. Now we are creating the new node. So what is the new index of the pre-index? 4. So pre-index of 4 is here 3. Pre-index of 4 is 3. Okay, so this 3, yeah, okay, this 3 is going to be a new node. So now pre-index is incremented by 1, 5. Then we are checking start index equal to last index. No, it is false. It is false because start index is 4, last index is 5. Again we are searching the node. What is the node? New node here 3. New node is here 3. So for this 3, what is the starting index? Starting index is 4, last index is 5. Then we are passing this values here. So in this one we are passing, so here starting index is 4, end index is 5. What is the value? New node. So new node is 3. So 3 is the new node data. We are checking where is the 3 available. So 0, 1, 2, 3, 4, 5. When you are apply the iteration which is available at index number 5. So the index number 5 is returning here. So index number 5 is returning here. So that is the thing. So here for the new node dot left, what is the new node? 3. So 3 dot left. So for 3 dot left, you have to pass start index. What is the start index? 4. Start index is 4. And what is the in index minus 1? In index is 5. In index minus 1 is 4. Okay, then we are calling recursion. Here when you are calling the recursion here, for that 4 comma 4 you are passing. So what is the 4 comma 4? So here this is false, which will not execute. So pre-index of 5. So this is the 5. Pre-index of 5 is here. What is the pre-index of 5? 6. So 6 is available here. Already 3 is written here. That 3 have to be drawn as a root node here. Now the 6 is this one. So pre-index is incrementing by 1. So 6 is the pre-increment. So now we are checking start index equal to last index. Yes, 4 is start is 4 is last index. So we're returning the new node. So what is the new node? 6. So 6 is the left side. 3 dot left. 3 dot left is 6. 3 dot left is 6. Okay. Then now we are checking 3 dot right. 3 dot right. So for 3 dot right, we are passing, what is the in index value here? In index value is 5. So 5 plus 1 is 6, right? Last index value is 5. So here we are passing 6 and 5. When you are passing 6 comma 5, here the starting index is 6, last index is 5. 6 greater than 5, so which is returning null. So 3 dot right is null. So this is the procedure to construct the binary tree by using in order and post order tree traversal. Thanks for watching.